process of fluids.
Pouring water. After all, it is a little water, not a stone.
Why did she cry when water fell over her body? Will it hurt? Do you think water exerts any force? Let's see what happens when a bottle partially filled with liquid placed above water surface. Place a tightly closed plastic bottle in water. What do you observe? Place an air-filled balloon over the surface of water. What happens? Can water exert force? Observe. A body situated in a liquid experiences two forces. One, the weight of the body acting downwards. 2. The buoyancy acting upwards on the body. Do you know why a mango falling from tree falls towards the earth? You know that the earth attracts all body towards its surface. That is the reason why mango falls towards the earth. This attractive force is the weight of the body. Newton is the unit of weight. Spring balance is used for measuring weight. This is a small stone piece. I am tying this on this spring balance. The weight of the stone is 1.1 Newton. Now the teacher weighs it with a spring balance. The weight of the stone is 1.1 Newton. That is, the force exerted by the earth on the stone is 1.1 Newton. That is the weight of the stone. Now he immerses the stone in water. When he weighs it in water, the reading of the spring balance decreases to 0.55 Newton. Why the weight of the stone is reduced in water? The reason is this. When the stone is immersed in water, the water exerts an upward force on it. Now here are two forces. One is the force that is exerted by the earth to its center, that is, the weight, and the other is the upward thrust exerted by water on the stone, that is the buoyant force. When a body is immersed completely or partially in a liquid, the liquid exerts an upward force on the body. This force is the buoyancy. Now you know the reason why when a bucket is immersed in water in the well, you feel some loss of weight. When you pull the bucket upwards, you feel more weight. Why? When the bucket was immersed in water, water exerts an upward force. That is called buoyancy. When the bucket was in the air, the force exerted by the earth on the bucket is greater than the buoyancy force exerted by the water on the bucket. Therefore, we feel more weight in the air than in water. Using a spring balance, the weight of a plastic vessel is measured. Weight of the vessel is 0.1 Newton. Now immerse the plastic vessel in water. Now the teacher weighs a metallic block. The weight of the metallic block is 2.1 Newton. Now the teacher immersed the metallic block in water and weighed it. Weight of the metallic block in the water is 1.4 Newton. The weight of the metallic block in air is 2.1 Newton. Weight of the metallic block in water is 1.4 Newton. Loss of weight is 2.1 Newton minus 1.4 Newton equals 0.7 Newton. Now the teacher weighed the overflown water. The weight of the bottle is 0.1 Newton. The weight of the overflown water is 0.8 Newton now. So the weight of the overflown water is 0.8 Newton minus 0.1 Newton. That is 0.7 Newton. The buoyancy exerted by the water on the metallic block is 0.7 Newton. The weight of the water is 0.7 Newton. The loss of weight of the metallic block in water is 0.7 Newton. This loss of weight is the buoyant force exerted by water on the metallic block. This principle is put forward by Archimedes and so-called Archimedes' principle. Archimedes was born in 273 BC at Syracuse, a port city in Italy. He lived during the rule of Hero II. King Hero commissioned a goldsmith to fabricate a crown. He commanded Archimedes to find out whether there was an impurity in the crown. This problem confused him. He knew that the density of pure gold could be calculated by dividing the mass of the gold bar by its volume. His confusion was how to calculate the volume without damaging the crown. When he stepped into his bath, he could see water overflowing. This made him realize that he could calculate the volume of an object by finding the volume of water displaced by the same. By finding the density and volume of the gold, he could prove that the crown contained impurities. Archimedes' principle. When an object is immersed partially or completely in a liquid, the buoyancy experienced by it will be equal to the weight of the liquid displaced by it. Now the teacher takes a metallic piece and weighs it. The weight of the metallic piece in the air is 2.1 Newton. He immersed it in water and weighed. The weight of the metallic block in water is 1.4 Newton. So the loss of weight of metallic block in water is 2.1 Newton minus 1.4 Newton. That is 0.7 Newton. Now he is salting the water. Now the teacher immerses the metallic block in the salt water. The weight of the metallic block in the salt water is 1.3 Newton. The buoyancy in the salt water is 2.1 Newton minus 1.3 Newton, that is 0.8 Newton. Loss of weight in water is 0.7 Newton. Loss of weight in salt water is 0.8 Newton. But the mass is the same. Now the teacher is going to immerse the metallic block in kerosene. He fills the vessel with some kerosene. He immerses the metallic block now in kerosene. The weight of metallic block in kerosene is 1.6 Newton. The weight of metallic block in air was 2.1 Newton. The weight loss in kerosene is 2.1 Newton minus 1.6 Newton. So the loss of weight in kerosene is 0.5 Newton. So the buoyancy in kerosene is 0.5 Newton. The weight of the metallic block in salt water was 1.3 Newton. The weight of metallic block in kerosene is 1.6 Newton. The relative density equals density of substance divided by density of water. Hydrometer is a device used to measure the relative density of a liquid. Lactometer is used to measure the relative density of milk. This is a plastic vessel. The weight of this plastic vessel is 0.1 Newton. This is a wooden plank. The weight of the wooden plank is also 0.1 Newton. Now he immerses this in water. When he immerses the wooden plank in water, the water overflows. The wooden plank floats over the water, it won't sink. Now the teacher takes the weight of vessel and the overflown water. Both weighs 0.2 Newton. The weight of the empty plastic bottle is 0.1 Newton. So the weight of the overflown water is 0.2 Newton minus 0.1 Newton equals 0.1 Newton. When wooden plank floats on water, the weight of the overflown water is 0.1 Newton. Principle of buoyancy. Weight of a floating body is equal to the weight of the liquid displaced by it. This is an aluminum foil. The mass of foil will not change, however we fold it. Now the teacher folds it to a small piece. Now he puts it in water. What do you observe? It sinks. This is the same aluminum foil. Now the teacher is going to make a small vessel using it. Now he puts it in water. What do you observe? Now the aluminum vessel floats. This is the same aluminum foil. When he folds it to a small piece, the density of the aluminum foil increases, so it sinks in water. The mass is not changed in both cases. When the density of any substance is greater than water, it will sink. When the density of substance is lower than water, it will float. This is kerosene. This is water. The density of water is 1000 kg per meter cubed. The density of kerosene is 810 kg per meter cubed. The density of kerosene is less than water, so it floats over water. The density of kerosene is less than water, so it floats over the water. Notice that even if we immerse a solid or liquid, when the density of the immersed substance is greater than the liquid in which it is immersed, the substance will sink. And when the density of the immersed substance is less than the liquid in which it is immersed, the substance will float. This is a plastic cover. The teacher is going to fill it with water. Now he closes the cover tightly. Now it is a closed system. Now he is going to make holes using a needle in the closed system. Now he presses the cover with his fingers. Look at the streams of water from all holes. We can see identical streams of water from all the holes. When pressure is applied at any point of the plastic cover, it is transmitted equally over the entire surface. This law was enunciated by Blaise Pascal. Blaise Pascal was born in France in 1623. He proved his proficiency in the fields of mathematics, physical science, philosophy, and theology. At the age of 16, he played a major role in the starting of projective geometry and probability theory, which are two research fields in mathematics. Pascal passed away on 19 August 1662 at the age of 39 due to poor health. Pascal's law. The pressure applied at any point of a liquid at rest in a closed system will be experienced equally at all parts of the liquid. Excavator. Excavator works on the principle of Pascal's law. Hydraulic brake of vehicles. Let's see how a hydraulic brake works. Hydraulic press. Hydraulic jack. This is glycerin. The teacher is going to put 1 or 2 drops of glycerin on the glass sheet. This is honey. He puts 1 or 2 drops of honey on the same glass sheet. This is water. He places a drop of water also on the glass sheet. Now he lifts the glass sheet. Let's see what happens. Water flows quickly, then honey. Glycerin flows slowly, then the other two. You have seen that different liquids flows at different speeds. Besides the friction due to the glass plate, there is frictional force between the layers of each liquid. It is this frictional force that prevents the flow of liquids. Water has lowest viscous force. Glycerin has greatest viscous force. Now you can understand that water has force. All liquids have properties like force, density, viscosity, etc., and different states. There are different types of fluids in nature. Let's observe, study, and understand them. You may discuss it with your friends.